Good evening, everyone. Thank you for joining the session. Let's travel back in time. It's the year 1919. We are in the USA. Every day, Jane and Alice deliver ice to homes and restaurants. People use that ice to preserve food by storing it into something that looks like a fridge. However, that fridge is not powered by electricity. Electric fridges were invented 3 years ago, but they are still not widely adopted. This will soon change, and as people buy more and more electric fridges, then ice distribution will not be needed anymore. Fast forward to today, you all know what happened with these type of fridges. It's the year 2024, we are in Vilnius, and AI coding assistants like GitHub Copilot are being used by more and more developers. Will generative AI and AI coding assistants replace developers? What do you think? Of course not. And that's exactly going to be the question we're trying to answer during this session. While AI coding assistants will not replace developers, they will certainly replace developers who don't know how to use these tools. By the end of this session, you will learn 3 key things. First of all, the weaknesses of these tools and how to mitigate them, using them more efficiently. Second, you will learn about the strengths of AI coding assistants like GitHub Copilot. And the third thing you will all learn is a glimpse of the future. How will the future of software development look like thanks to the introduction of these novel tools? My name is Ioannis Kolaxis. I am a director at Accenture, and I am based out of Athens, Greece. I started programming when I was in primary school using a computer that had a green screen. And my first job was as a programmer developing Java applets in Java version 1.2. Today, I want to share my experience of using GitHub Copilot and other tools like ChatGPT and how I think this will transform the way we're doing as software engineers. Before we start, I have a question to ask. Do you use AI coding assistants in your daily work? Please raise your hand if you do. Awesome. I see quite a few hands here. We will first start by diving deeper into the weaknesses of these tools, and these are 3 key weaknesses. First of all, when we generate new code, this tends to be functionally incorrect. What we mean by that is when we run unit tests, these unit tests will likely fail. This brings us to the second weakness, which is quite similar. When we refactor existing code, the code usually compiles, but it won't pass the unit tests, but it will break the existing code. And then the third weakness is that these tools make it harder to maintain applications by introducing duplicate code fragments. We will dive deeper into the details into this section. Let's first start by an example of a prompt in Java. This is the kind of prompt that we provide to an IDE like Visual Studio Code. As you can see at the bottom, we have the method signature in Java, which has clause elements. And we also provide 2 parameters. The first parameter is a list of numbers, and the second one is the threshold. What we want to achieve here is to examine the distance between all the numbers in the list and find whether the distance between them is closer than the threshold. As you can see at the top, we provide some detailed comments on what we want to accomplish with this Java method. We also provide 2 examples that look like unit tests, where we provide the input parameters and what the expected output should be. And this is as detailed as possible so that we help an AI coding assistant like GitHub Copilot to generate us the method body. Let's take a look at a demo of how this works in practice. It's exactly the same code prompt like in the previous slide. We hit enter and expect that GitHub Copilot will recommend something. Then we get the suggestion on the right side by GitHub Copilot. We inspect this, we review it, and then click accept. And we do have the code now. Will this code work? Who knows? Someone, a human, a developer, has to test and verify this works. And that brings us to the first weakness of these tools. When we generate code, this may build, this may compile without any issues, but when we run unit tests, this will likely fail. Here you see the data coming from a research at Bilkent University in Turkey, where they provided 164 different problems, different prompts. And then they ran the unit tests that they had for these problems. They used ChatGPT, GitHub Copilot, and Amazon Code Whisperer. And as you can see, ChatGPT performed better compared to all the others, generating the correct code only for 65% of these prompts. For the rest, 35% of the prompts, some or all of the unit tests failed to pass. Likewise, GitHub Copilot generated correct code only for 46% of the problems, of the prompts, and Amazon Code Whisperer generated correct code only for 31% of the problems. What they did next is to look closer into these failed prompts, and what they realized is that the prompts that failed to generate the functionally correct code were the ones that were the most complex, the longer and most complex prompts. Therefore, the key to generating functionally correct code is to provide short and simple prompts when working with coding assistants. They also provided some method names that were not descriptive, some generic names like foo and bar, which didn't disclose the intent of what the developer wanted to build with that method. When they did that, then the likelihood of generating incorrect code increased. Therefore, we also need to provide descriptive method names that show the intent of what we want to achieve. And that brings us to the best practices that 10x developers apply during the job. We all need to use, as humans, our ingenuity when working with complex problems, taking these big complex problems and breaking them into smaller, simpler problems. Only when we do that can we provide the right prompts to AI coding assistants, which will therefore generate the functionally correct code. So it's about bringing humans and technology together. It's not about replacing the developers. We will always need a human who can analyze problems and break them into smaller, less complex problems. Summarizing, to be able to mitigate this first weakness of generating functionally incorrect code, we must all write code prompts that have clear and accurate problem descriptions, that we include some kind of unit tests in the comments of how the method should behave, and also we should be providing descriptive method names that disclose the intent of what we want to build. Moving on to the second weakness, we have a research from CodeScene where they performed 100,000 refactorings for different code smells in JavaScript and TypeScript code. And they found similar results. As you can see, Google's Palm model performed correct refactoring only in 37% of these refactorings. GPT 3.5 worked correctly only in 30% of these refactorings. And Code Llama, a fine-tuned model of Code Llama, performed correctly only in 18% of these refactorings. They also looked closer into these failed refactorings, and what they found was that whole blocks, if-else-if blocks, would be dropped during the refactoring. So if we had some code with if, else if, and then else if, some of these else if would be completely dropped during the refactoring. They also realized that AI coding assistants would usually mess Boolean logic by inverting it, inserting this exclamation mark into the code, although it was not needed. Therefore, to mitigate these weaknesses while doing refactorings, we all need to be very careful reviewing the code. We need humans to review the code. And we also need to write unit tests to verify that the refactor code works correctly. This is not something new. These are all practices that we've been applying for the past 10 years or more as software developers. So it's not anything new. On the contrary, only developers that are familiar with these practices can safely adopt generative AI and AI coding assistants. Let's have a quick quiz. As developers, where do we spend most of our time? Is it A, writing new code? Please raise your hands if you think that we spend most of our time writing new code. Anyone? I see a couple of hands. Great. Or is it B, reading code, trying to understand how it works? Wow, I see more hands. Or is it C, waiting for a full build to complete? Yeah, I had that problem as well with a legacy application that took forever to build. Or could it be D, in other activities like meetings or drinking coffee? No hands? Well, according to research, we spend 70% of our time reading code, especially for legacy applications, trying to understand what that code does. And we only spend 5% of our time writing code. It's funny because all the hype with AI coding assistants is that they help us write code faster. Who cares about writing code? The struggle is when reading code, not when writing code. That's where the big issue lies in software development. And that brings us to the third weakness of AI coding assistants. This is based on a research from GitClear, who analyzed 153 million lines of code from January 2020 to December 2023. What they discovered is that since the introduction of GitHub Copilot and ChatGPT, there has been a significant increase in duplicated code, that is, code being copied and pasted across the source code repository. First of all, why does this happen? It happens because tools like GitHub Copilot only recommend adding new code. They never recommend reusing existing code. For example, they never recommend using an existing Java method from our source code repository. And they never recommend merging duplicate code or deleting dead code. They only recommend adding new code which may be already there in our source code repository. And then why is it bad to have duplicate source code? What's the problem with maintainability of a software application? Well, it takes more time if you have to read the same code being duplicated in 2, 3, 4 or more places in the source code. And the real struggle is when you have to change that code to fix a bug. You need to make sure that you fix it in multiple places and test it in multiple places, because usually you have to test for different scenarios that go through that code path. And after these different duplicate code get evolved, it's even harder to consolidate them. Therefore, it takes more time to maintain applications that have duplicate code. And the common issue that we get to see nowadays is that we have essentially automated the practice of copying and pasting. Previously, we would be searching for a solution on the internet. We would likely find it on Stack Overflow. We would copy the code ourselves and paste it into the source code repository. This was a conscious action. But nowadays, it's an AI coding assistant like GitHub Copilot that automatically copies and pastes code into our source code repository. So that's what really happens. Moving on, the same research discovered that there has been a decline in the code reuse and code refactoring, which is essentially the same observation. As we mentioned, these tools do not recommend reusing existing code or refactoring existing code. What's interesting about this research is that they mention that the results of the code being written by AI coding assistants resembles the work of a short-term contractor. What's wrong with a short-term contractor? A short-term contractor may be an excellent developer, for example, in Java. The problem is that when they join a team, for example, a team that maintains a legacy application, they are not aware of the existing code. It's easier for them to write new code instead of reusing existing code. The strength of existing code is that it has been tested in production for many years and it proved to be reliable, whereas new code is not tested. Therefore, that's the problem and the resemblance of generating code with AI coding assistants, which resembles a lot with the work of a short-term contractor. Therefore, to mitigate this weakness that we just mentioned, as 10x developers, all we need to do is to try to reuse existing code or refactor existing code instead of generating new code with AI coding assistants. And that's also where humans differentiate from AI coding assistants. We can use our intelligence to reuse code, delete code, or merge duplicate code, something that these tools cannot do, at least not today. And that's why 10x developers manage to read and maintain their code at least 10 times faster. Next, we are going to also explore the strengths of these tools. They also have some significant strengths that we can all leverage. First strength is that they can help us explore new technologies and develop prototypes much faster than before. The second strength is that they can help us understand code and improve its performance. And the third strength is that they can help us build unit tests that act as a safety net whenever we make changes to our code base. Whenever I visit a new city like Vilnius, I usually use something like Google Maps to walk around the city and explore a new location. We all do that. When we visit new places, we use Google Maps or Apple Maps to explore places we haven't been before. I feel the same way about tools like GitHub Copilot. Whenever I need to explore new technologies, new areas, it's really helpful using such a tool to build faster. As part of my job role, I need to develop prototypes. We also call these throwaway prototypes to experiment with new technologies. Previously, I would need 4 or 5 days to build such a prototype with a new technology. But nowadays, I've found out that using a tool like GitHub Copilot, I can build these prototypes much faster, being able to deliver these in 1 day or even faster. And one more advantage is that while developing these prototypes, I can stay more focused. Previously, I would have to be on the lookout, searching on the internet for information on how to build something using this new technology, reading blogs, watching videos, and after 1 or 2 hours, I would be wondering to myself, what am I doing here? Why am I searching for that information? I need to build something. I need to build a prototype. With this tool, with GitHub Copilot, for example, I can stay focused and do all the job inside the IDE, iterating faster until I can deliver a proof of concept. Therefore, 10x developers use AI coding assistants to move fast and break things. And what we mean by breaking things is that the way we learn new things. If you don't break things, then you don't learn. And that's exactly the essence of using these tools to learn faster, being able to iterate as you break things, iterate faster until you get things right. And now that's the second strength of using these tools to be able to understand code. And once we understand existing code, then we can also improve its performance. Can you figure out what this algorithm is doing? What algorithm are we using here? Yeah, excellent. That's bubble sort. You got it right. However, I wouldn't be able to find that on my own. That's why I would use some help from GitHub Copilot, where you can actually ask GitHub Copilot what the algorithm is. Here you can see this in action. On the right, you see GitHub Copilot chat, and we ask, what is the algorithm used in the selected code? And then after taking more time than you needed to answer the question, it will tell us that this is bubble sort and also provide some details on how bubble sort works. So it tells us it's a simple sorting algorithm. It repeatedly steps through the list, compares adjacent elements and swaps them if they are in the wrong order. And then we can provide a follow-up question asking for alternative sorting algorithms that are more efficient than bubble sort. And we get a list of alternative algorithms, alternative sorting algorithms like quick sort, merge sort, heap sort, team sort, and radix sort, along with their time complexity. Therefore, we can evaluate all these alternative options and then again use GitHub Copilot to rewrite our code, to refactor our code, to make it more efficient. The point I want to make here is not so much about bubble sort versus an alternative sorting algorithm, but how it can help us understand code that has no comments, just like the sorting algorithm that I just showed you. And when we compare the performance of bubble sort versus quick sort, you can see that quick sort performed 95% faster when sorting an array of 1000 numbers. Therefore, we can get a significant improvement in our performance just by asking what algorithm are we using and using an alternative, more efficient algorithm. Therefore, one thing that we need to keep in mind is that 10x developers can use GitHub Copilot to better understand the code, how it works, and identify opportunities for drastically improving the performance of our code. That's why the code that 10x developers write runs 10x times faster or even 100 times faster. The third strength of using these tools is that they can help us generate unit tests, especially for legacy applications where there aren't any unit tests present. And these unit tests will serve as some kind of a safety net. Whenever we make changes to the existing code, we can fall back into these unit tests and use them as a means of checking that the changed code does not break existing functionality. Let's see how this works in practice. We have again the same method, has_close elements, that we showed previously, for which GitHub Copilot generated the code. And what we do here is we ask from GitHub Copilot chat to generate the tests. You can see that it has automatically generated a test plan of all the scenarios it will check for. For example, first scenario, no elements in the list. Second scenario, only one element in the list. Third scenario, multiple elements with close distance or not close distance. And it also generates the code with the unit tests in Java, in JUnit tests. And then we can copy that code and paste it. This time we are allowed to copy and paste. There is no issue with that. And after we've created the unit tests for that code, then we can also run that code, run these unit tests to verify that our code works correctly. Here you can see all the unit tests. So test no elements, test one element, test no close elements, test has close elements. We test all the individual scenarios. And here we run the tests. And as you can see, all the tests passed. I know this can be a bit contradicting because when we examined the weaknesses, we told that these tools tend to generate incorrect code. And now, when generating unit tests, this is one of their strengths. However, if you get to see at the code that they generate, it's much easier for us to be able to review the unit tests that they created. The code is much simpler. So again, we always need a human to review the unit tests that we created. And that's what 10x developers do. This time they move fast and they don't break things because they have unit tests that act as safety net. And that safety net allows them to refactor the code, for example, using GitHub Copilot. That's how we use one strength against the weakness that we presented earlier. Now let's take a look into what the future holds for software development. Will generative AI replace developers or not? Let's take a look at a demo of using ChatGPT. We provide an image to ChatGPT and ask from ChatGPT to describe that photo. As you can see, it's a dog that wears headphones. And what's quite impressive is that we get a detailed description from ChatGPT. The photo shows a dog with curly fur wearing a pair of headphones. The dog appears to be enjoying the music with its eyes closed and an expression of contentment. The sky in the background is clear and blue, giving the image a cheerful and serene atmosphere. The dog is also wearing a blue bandana around its neck. It's impressive. If you asked me, I would just tell you I see a dog. And I would also mention the headphones. Nothing more. How does this happen? Here you can see the 3 steps. In the first step, we provide the photo to the large language model, in our case ChatGPT, and in the third step, we get the description. Is there an alternative way of building an application, for example in Java, that could implement the same functionality as ChatGPT? Could we build somehow a Java application that when we provide a photo, it will generate the description of that photo? And that should work for any photo, not just that dog photo. That's impossible. No matter if you use Java or Rust or any other programming language, we cannot do it with the conventional tools we've been using so far. Therefore, there is a new field of problems that we can address with large language models like ChatGPT. Looking under the hood, if you think about it, we are essentially programming large language models using vast volumes of data, like text, audio, and video. It's a different kind of programming model. And when we do that, we get billions of parameters known as the weights and biases. For example, for GPT-3, we have 175 billion parameters, each one taking 2 bytes. Therefore, we have 350 gigabytes of parameters. You can think about it like compiled code. However, if a human tries to inspect, tries to debug that code, that's impossible. There is not a single human who can fully understand how LLMs work, who can debug all these billions of parameters. Whereas for conventional applications, for example Java applications, most of us here can understand Java code. When we compile the Java code, we get the Java bytecode. Fewer of us can understand bytecode, but still there are some humans who can understand and debug bytecode. And when we run that bytecode, it gets converted into machine code, assembly code. There are fewer of us who understand assembly code, but still there are some humans who can reason about it and debug when something goes wrong. So these are the key differences between conventional programming in Java and this new type of programming, if we can call it that way, with large language models. It's time for an interesting coding challenge. How could we build a software application to find the cheapest flight tickets from Vilnius to travel to the upcoming Oracle Java 1 conference? First of all, we don't specify here where this conference takes place or the dates during which this conference takes place. Therefore, we would have to build some kind of an application that searches on the internet, finds the relevant websites, then parses and scrapes somehow that information, and then queries one or more websites to look for the ticket prices. That would be a lot of work. Or instead, we could use one of the custom ChatGPTs. This is one provided by Kayak, where we type the same question, and then the large language model figures out on its own that it's lacking critical information such as the dates and the location of the conference. It searches automatically on the internet and tells us that the conference takes place from March 18 to 20 at Oracle Conference Center in Redwood Shores, California. And you also get to see the references, the links that it used to find and extract that information. And then it also asks if we would like to travel in economy or some other class. So we reply we're interested in economy class, and then it follows up with an additional request. This time it performs a query to Kayak website, and it will find all the relevant flights for these dates and for that location, from Vilnius to California, USA. And here you also get to see the JSON request we sent to kayak.com. You see the origin, the destination, the departure date, the return date, and the cabin class. So it looks like magic, but it's not really magic. And that's the new paradigm in programming. We can also call it codeless. It's a new way of building software, where we have a user asking a question to a large language model. That large language model figures out what information it needs to accomplish these tasks, and then it queries on its own one or more systems. This could be an internet search, or a query to a database, or a query to an ERP system like the one for buying flight tickets. Then it collects all these replies, it processes them, and then replies back to the user the most relevant answer. Summarizing what we talked about are the 3 weaknesses and 3 strengths of AI coding assistants. First weakness is that these tools generate functionally incorrect code that doesn't pass unit tests. The same happens with refactored code. Whenever we refactor code, it is most likely that we will break the code. And also we must remember that they copy and paste code in the background, therefore negatively impacting the code quality. And then we also talked about the strengths of these tools, helping us explore new technologies faster, moving fast and breaking things. The second strength is understanding code and identifying opportunities on how to improve its performance. And then the third strength is generating unit tests that act as a safety net. Summarizing the 3 different development paradigms that we see today are the ones shown here. So on the left, we have the conventional model where humans write code, or GitHub Copilot writes code, but what's common here is that we write code. The second paradigm is using vast volumes of data like text and images to program large language models or train them. And then the third and most interesting paradigm is the one where we integrate large language models with conventional systems, with conventional programming applications to create magic, like the one we witnessed when searching for tickets, for flight tickets. And now it's time for the million-dollar question. Will artificial intelligence replace developers? Let's draw some inspiration from commercial airplanes. The first autopilot was invented in 1912, more than 100 years ago. Still, when flying, for example, from Greece to Vilnius, I've noticed that there were 2 humans piloting the plane. It wasn't in autopilot mode. And the reason we need humans in the cockpit, in the airplane, is because they have the broader picture of everything. weather, the systems, and if something goes wrong, they are the human in the loop to act on the problem and fix things. In the same sense, we will always need humans, developers, as the humans in the loop, especially for mission-critical systems, like the ones flying airplanes, or the ones that process trillions of euros being transferred in the financial services industry, or the systems that help us generate power. We have so many mission-critical systems, and for each one of these systems, we will always need humans in the loop. What may change is the nature of our job as software developers. Looking back to the 1950s and 60s, every developer had to write code in assembly. Therefore, they needed to know the precise architecture of the processor for which they wrote code. When high-level programming languages were introduced, like Fortran, then developers suddenly stopped learning about the hardware that would run their machine code. And that's what most of us do today. We program in high-level languages like Java. In a similar fashion, our job may evolve to provide high-level language, which is natural language, English. We may be providing instructions in English language. Therefore, the job role of the developer may gradually change to be like the job of a software architect today, or a product manager who has the broader overview of how the application should function and how the different systems should interact between them. Therefore, the developers of the future may be mostly architecting applications than writing high-level code in Java or other languages. And now that's the call to action to everyone who aspires to become a 10x developer. The most important thing is to remember to write unit tests and perform code reviews. That's not a new practice. As a matter of fact, only teams that apply these practices can safely adopt AI coding assistants and generative AI tools. The second thing we need to do is to use these tools to better understand existing code, especially legacy code, and identify opportunities to further improve the code. And then the third and most interesting part is around exploring these new paradigms in software development, especially the ones where we integrate large language models and conventional applications to create magic. I'm open to any questions you may have. You can also connect with me, and I will be also around at the conference tomorrow. So any questions you have, you may ask them either now or later in the conference.